All right, so today we're going to look at the Mission 3 Part 1 review. So on your document, you guys will go ahead and make a copy and type your name there and share it with me. So this first one here is 40 times 30. I want you to go ahead and try to solve it using an area model, but if there's another method that works better for you, go ahead and do that. So I'm going to give you some time to try that one on your own. All right, so with this one, if we're to use the area model, we have 30 and 40. So what we can do is we can look at this as 3 tens times 4 tens, which gives us 12 tens, okay? Which is equal to 1,200, all right? So another way that we can look at this is by taking 40 times 30 and looking for the basic fact, 4 times 3, which is 12, and then tacking on 2 zeros and get 1,200, all right? Let's go ahead and look at this next problem. 5 times 374, you can use an area model or any other method that works for you. All right, I'm gonna go ahead and demonstrate this with an area model. So I have 5, 300s, 70, and 4. So I'm gonna take each of these and I'm gonna multiply it and then add all these numbers together. So 5 times 300, 5 times 3 is 15. Tack on 2 zeros, I get 1,500. For this one, I have 5 times 7 is 35. Tack on 1 zero. 5 times 4 is 20. Okay, so now I'm gonna add all these together. And I'm gonna get 1,870 for my answer. All right, now let's go ahead and look at 4 times 29. Solve this in any method that works for you. All right, so for this one, there's a couple ways you can approach this. I have 29 times 4. I can solve this using the traditional algorithm by asking myself 4 times 9, which equals 36. Put my 6 here, carry my 3 over. Or I can do 4 times 2, which equals 8, plus 3 more, which equals 11. And have my answer as 116. The other thing I can do is to do kind of like that area model distributive property combo and add up my answers. So I can ask myself 9 times 4 is 36, and then ask myself 4 times 20, because I have 2 tens times 4, and then I can end up with 80, and then I can add those together and get 116. So it just depends on which method that you found yourself to be more comfortable with. So either way, your answer is 116. Okay, the next one we're gonna look at is 5 times 231. So go ahead and solve that in any method you're comfortable with. All right, so I'm gonna go ahead and show you in both the traditional algorithm way and with an area model. So I have 231 times 5. 5 times 1 is 5. 5 times 3 is 15. Put the 5 here, carry a 1 over. 5 times 2 is 10, plus 1 more is 11. 1,155. If I chose to use an area model, I could put a 5 here, 200s, 30, and 1. 5 times 200 gives me 1,000. I know this because 5 times 2 is 10. Tack on 2 extra zeros. 5 times 30. 5 times 3 is 15. Tack on 1 more zero. 5 times 1 is 5. So then I go ahead and add all these together and I get 1,155. All right, here is the last one, 7,032 times 8. Go ahead and try this one on your own in any way that makes sense to you. All right, so if I was to solve this with the traditional algorithm, I would do 8 times 2 is 16, drop my 6, carry my 1. 8 times 3 is 24, plus 1 more gives me 25, carry my 2. 8 times 0 is 0, plus 2 more gives me 2. 8 times 7 is 56, and I'd end up with 56,256. Now, say I wanted to use the area model with that distributed property without actually drawing out the area model. So I would take care of my ones place first. 8 times 2 is 16. 8 times 30. 8 times 3 gives me 24, so tack on a 0, 240. 8 times 0 hundreds gives me 0. 7 thousands times 8 gives me 56,000. Then I'd add that all up together, and I'd still get 56,256. So once again with this, it's just the method that you're most comfortable with. Now I have some word problems here. A stadium has 2 rooms. Room A has 8 rows of 22 seats in each row. Room B has 2 times as many seats as room A. How many seats are there in both rooms? Go ahead and try that one on your own. Okay, so room A, they're telling us to solve, we have 8 rows of 22. Well, I'm just gonna do 8 times 22 to solve that. Room B is 2 times as many seats as room A. So for room B, I'm gonna take A times 2. And then they wanna know how many seats are in both rooms. All right, so first I'm gonna take 22 times 8. I'm gonna get 176 seats for room A. So 176. And then they told me that room B was twice as many. So I'm gonna multiply that by 2. 352. Now they wanna know the total of both together. So I'm gonna have to add both room A and room B. And I get 528 seats. All right, moving on to this one. Ms. Schmidt's rectangular yard has a width of 4 feet and an area of 32 square feet. So you need to solve for the length of the yard. Go ahead and try that one on your own. All right, so my rectangular yard has a width of 4 feet, and then an area is 32 feet squared. Well, it looks like I need to ask myself, 4 times what gives me 32? Well, I know that 8 times 4 is 32, so that must mean that the length of my yard is 8 feet. All right, we have one more question. Once again, Ms. Schmidt's rectangular yard has a width of 4 feet and an area of 32 square feet. Ms. Schmidt wants to put a fence around the yard. How many feet of fencing should she purchase? Go ahead and try that one on your own. All right, so we solved in the last problem for the width, or I'm sorry, for the length. And we found out that these were the dimensions of my yard. So I want to put a fence around it. Well, that means I need to solve for the perimeter so that I know how much fencing I need to buy. So I can say that perimeter is 2 times the width plus 2 times the length. So perimeter equals 2 times 4 plus 2 times 8. So perimeter equals 8 plus 16. Perimeter is going to equal 24 feet. So I need to buy 24 feet of fencing. I hope that this review helped you. If you have any questions still, please let me know, and make sure that you put pictures of your work and the answers on the slides and share them with me.